Hello everybody, in this video we will discuss chapter 24 section 1 in zero-wave physics. In this section we will study the electric flux. So what is the electric flux? The electric flux is the rate of flow of electric field through a given area. To understand the meaning deeper, let's look at figure A and figure B. We can see that there are two flat surfaces and there are these lines that represent the electric field magnitude. So logically here figure A has higher electric flux than figure B. As the number of lines in that specific area increased, we can conclude here that phi, which is the symbol of flux, equals E times A, where E is the magnitude of the electric field and A is the area perpendicular to the field. So what if the electric field is not perpendicular on the area? At this point we will get its resolution by multiplying the electric field by cosine theta, so it's equal EA cosine theta, which equals the dot product of E dot A, where the direction of A vector is perpendicular on the area. Theta is the angle between the direction of A vector and the electric field. Well, theta also is an indicator if phi is going in or out the surface, because if the angle is less than 90 degrees, then its cosine is positive, so phi is positive. So it's going out as shown in figure A. And when the angle is more than 90 degrees, then its cosine is negative, so its phi is negative, so it's going in as shown in figure B. Okay, what to do when we deal with the flux of a non-uniform shape? To calculate the flux here we have to get a very tiny piece of area which is called dA and multiply it by EI, which equals d phi, and by integrating both sides we can say that phi equals the integral of EI dot dA. Let's see what if we have a closed surface. Well, a German scientist that is called Johann Gauss stated that any closed surface is called Gaussian surface. And to get the flux, you will have to get the dot product of the integral of E dot dA. Let's look at example 1. To calculate the flux in that Gaussian surface, we have to calculate each integral and add them to each other. And since that the face number 3 is parallel to the direction of the electric field, therefore theta equals 90 degrees. So cosine 90 equals 0. Therefore, the third integral is cancelled. Looking in the other two integrals, we can see that the first face makes an angle of 0 degrees. So cosine 0 equals 1 and the surface makes an angle of 180 degrees. So cosine 180 equals -1. So by taking the constants out of the integrals, we can now integrate the dA, which will equal pi r squared in both integrals. And by subtracting the two terms, we can deduce that the flux equals 0. Well, that's all we have for today. Thanks for watching.